Hi, everyone. Thanks for showing up for your learning. And today our topic is how many roots do these quadratics have? How many x-intercepts will there be? We actually have a tool that's going to show us the number of roots, and we'll learn to use that today. So, just to review, we're going to start by graphing three different quadratics, and we're going to use the quadratic formula to do so. So let's take a look at this one here. We know that when we have a quadratic that's written in the form of y equals ax squared plus bx plus c, that we can extract our numbers a, b, and c to graph this quadratic. So a here is 1, because I see there's no number multiplying x, so it's just 1x squared. B is negative 6, and c is 4. Now, we don't have to use the quadratic formula in this case. This one is factorable, but for argument's sake, let's use the quadratic formula anyway. So, the quadratic formula, does anyone have the song in their head? Keep going, Cade. Over 2a. Good. There we go. So negative b plus or minus the square root of b squared minus 4ac over 2a. So you copy it out every time. This will help you remember, and it will help you avoid errors when you copy this out, because you can then substitute carefully. We've got a nice list of numbers here that we can use to substitute into those values. So let's find out what our x-intercepts are. So b, negative 6 is positive 6. I can write it out as negative 6 plus or minus the square root. I write a big long square root sign. I put in negative 6 for b, so I square that. And then I have minus 4 times a times c. All right. That one won't factor? Oh, interesting. Anyway, let's keep going. So negative 6. Oh, and then all over 2a. So that's just 2 times 1. So all I've done here is everywhere I saw b, I put in this value. Everywhere I had a, I put in that value. And everywhere I had c, I put in that value into the quadratic formula. And that's it. Now we evaluate with BEDMAS. We're going to want to evaluate inside the square root sign first. That's like a big bracket. So we're going to evaluate that all first. So let's go. We have x is equal to negative 6 is just 6, plus or minus this great big square root here. Negative 6 squared is 36, and your calculator will tell you if you don't know. Negative 4 times 1 times 4. Well, negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. Okay. So we have 36 minus 16 in the brackets. I just evaluated inside there. And then on the bottom is 2 times 1 is just 2. Okay. Now this is equal to x is equal to 6 plus or minus the square root of 20, because that's 36 minus 16 all over 2. Okay. Turns out this one would not have factored, which is fine. And let's take a look at what these values are for x. So what we're going to do is kick on our calculator. We don't happen to know the square root of 20 off the top of our heads. So, but we do know that it's going to be between 4 and 5, because 4 squared is 16, 5 squared is 25. So the square root of 20 is going to lie in between their square roots. So let's try it. 20, and I take the square root of it. It turns out to be 4.47. 4.5 is going to be a lot of detail for our purposes. We're just creating a graph, so 4.5 is fine. We're going to round to the nearest half. And so this is going to be x is equal to 6 plus 4.5 over 2, or x is equal to 6 minus 4.5 over 2. All right. So 6 plus 4.5 over 2, that's 10 and a half over 2. 10 and a half over 2 is 5.25. So let's put that on here. Do I have an error in here? No, I don't see an error. Okay, so this is going to be equal to roughly 5. So go ahead and put that on your graph. It's about out there. Okay, and then this one, 6 minus 4.5 over 2. Well, that's going to be 1.5 over 2. 1.5 over 2 is just a little bit less than 1. And that's right there. Why is this doing this? And why am I confused? So let's take a look at it in Desmos to see if that matches what we're seeing there. So let's go, a Desmos here. And we're just going to dump it in. X squared minus 6x plus 4. Yeah, there it is. So there are the roots that we found. A little bit less than 1 and a little bit more than 5. So we have that there. Those are the roots. Now let's go ahead and find the vertex. So to find the vertex, we're going to use the formula negative b over 2a. This part of the quadratic formula that we looked at on Friday, before we do this plus minus the square root, that gives us the x value of the vertex. That's the spot in the middle before I add and subtract to either side. So let's find negative b over 2a. If I put in here, just close to my a, b, and c's, if I look for negative b over 2a, well, I'm just going to substitute in there for these values. Negative 6 is negative b over 2 times a. Well, that's just 2 times 1. So this is equal to 6 over 2. 6 over 2 is equal to 3. So the axis of symmetry is that x is equal to 3. So we can go ahead and put that onto our graph as well. And we know that the middle of this quadratic is going to lie somewhere on this axis here. Okay, cool. There we go. So now let's find out where it is in terms of how high and how low. We know that the middle is at x is equal to 3. Let's put that in. So if I take this function over here, f of x, and I copy it out, let's do this in red. Over here, f of x is equal to x squared minus 6x plus 4. And I know that x equals 3 will be the x value of the vertex. I can just evaluate this function at the value 3 to get 3 squared minus 6 times 3 plus 4 will give me the y value of this vertex. 3 squared is 9, minus 6 times 3. 6 times 3 is 18. So 9 minus 18 is negative 9. Let's just write it out. 9 minus 18 plus 4. And if we work that out, that's equal to negative 5. So our vertex is down here, just off the graph, at negative 5. Now we can join the vertex with these points to have a graph of this function. Like that. And this is f of x. So that's how we can use the quadratic function to complete a graph of these types of equations. You use the quadratic function to find the location of your roots, then use the negative b over 2a to find the axis of symmetry, input that value for y to find, for x to find the value of y at the vertex. Next, if we take a look at g of x is equal to negative x squared minus 4x minus 4. All right. Let's identify our a, b's, and c's. A is negative 1, because this is ax squared plus bx plus c. So b is negative 4, and c is negative 4. So we have our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And then go ahead and just input these values to work out where this quadratic touches the x-axis. So we're going to find a negative b is negative 4. Just substituting in here for b. And plus b squared will be negative 4 squared minus 4 times a, which is negative 1, times c, which is negative 4. Notice that when I substitute in for a and c, I always put those into brackets to remind myself to multiply. All over 2a. So this is 2 multiplied by negative 1. Okay, and now simplify, just evaluate. This is going to be equal to negative 4 is just 4 plus or minus the square root of negative 4 squared is 16. And then over here, I do negative 4 times negative 1 times negative 4. I notice 3 negative signs. 3 is an odd number. So my answer as I multiply 3 negatives together will be negative. And 4 times 4 is 16. So this will be 16 minus 16 inside the square root. All over 2 times negative 1. So this is all over negative 2. Okay. Now, 16 minus 16, well, that's just 0. So this is equal to 4 plus or minus 0 all over minus 2. If I add and subtract 0 from something, it doesn't change. I'm 42 plus or minus 0 years old. Strange way of saying my age, but it's true. And so this is just the number negative 2. 4 divided by negative 2 is negative 2. So that's the value of my root, is just x is equal to negative 2. We can go ahead and put that on here. Negative 2 is the value of my root. All right. I can also see from this one that the y-intercept here is minus 4. So it's going to go down and go through that. The step pattern is negative 1. So from the vertex, I go over 1 and down 1, over 1 and down 3. So that gets me to there. And then by symmetry, it's over here and over here. Oh, sorry. How did I know to do that? I know that this is the vertex. Let's take a look at this one in Desmos. So if we put this one into Desmos, we have negative x squared minus 4x minus 4. And there it is there. Notice that it has exactly one root, and that the root is also its vertex. So whenever you find this, that something has plus or minus 0, when the contents of that square root is 0, you know that the root is the vertex and that there's exactly one root, because it's plus or minus 0 from that. If we take a look at the negative b over 2a, if we had used negative b over 2a, this is what we would have found. So negative b over 2a, so substitute in. B is negative 4, so this is equal to negative 4 over 2 times a, so this is 2 times negative 1. So this will be equal to positive 4 on the top over negative 2, because negative 4 is positive 4. So plus 4 over negative 2, that's equal to negative 2. So the equation of the axis of symmetry was the same as the equation of the one and only root. If we put in negative 2 here for g of x, and I evaluate here g at 2, negative 2, what we're going to find is then I have, this will be equal to negative 2 squared minus 4 times negative 2 minus 4. Just substituting in negative 2 for x wherever I see x in this equation here. So let's evaluate. Negative 2 squared. Well, negative 2 squared is negative 2 times negative 2. That's positive 4. But I want negative that, so that's minus 4. Negative 4 times negative 2 is plus 8. And then minus 4 is just minus 4. So negative 4 plus 8 minus 4 is 0. So the y value of this one's vertex is 0. So that's showing us that this point here is indeed the vertex. And g of x looks like this. And for a change of pace, let's now take a look at h of x. So h of x, let's first try and find where this one's vertex is. We can do this in any order. So I'm going to look at negative b over 2a to find the axis of symmetry for this function here. My a value is 1 over 2, my b value is 2, and my c value is 3. So let's input those in here. Negative b is going to be negative 2 on top, divided by 2 times a. A is 1/2. So 2 times 1/2, half of 2 is 1, so this is equal to negative 2. Okay. So we know that the x value of the vertex is negative 2. So this one also has an axis of symmetry over here at negative 2. And let's find the y value of the vertex. So to find the y value of this vertex, I'm going to substitute in negative 2 for x in all of these places. So I'm going to find h at negative 2. And so that's going to be equal to 1/2 multiplied by negative 2 squared plus 2 times negative 2 plus 3. Okay, so this is equal to, I have to do bedmas here, so negative 2 squared first because it's an exponent. That's going to be 4. So I have 1/2 times 4 plus 2 times minus 2. So that's going to be minus 4 plus 3. Okay, and so that's going to be equal to 1/2 times 4 is 2. 2 minus 4 plus 3 is equal to 1. So the y value of this vertex is 1. So let's put that in there. Here is h of x's vertex. Okay. And let's take a look at other things that we notice about h of x. Here is its y-intercept at 3. So I can put that on the y-axis up there. And I can notice that this is a parabola that has an a value that's positive. That means it opens upwards. So I can look at this and I can see this is never going to hit the y-axis. It's going to go up this way. It's never going to hit the x-axis, sorry. It's going to go up that way. Let's take a look at it in Desmos before we try using the quadratic formula on it. 1 over 2 x squared plus, was it 2x plus 3? Yeah, there it is there. So here is its y-intercept of 3. It's vertex at negative 2, 1. And it's never touching the x-axis. It has no roots. Let's take a look at what the quadratic formula says when we try and apply the quadratic formula. So if I come in here and zoom in so I get some space and move my face here and get my quadratic formula pen out, I know that my a is equal to 1/2, my b is equal to 2, and my c is equal to 3. Let's write that better. C is equal to 3. So here, when I use, I'm just going to write out h of x again. H of x is equal to 1/2 x squared plus 2x plus 3. And I'm going to zoom in so that I have more space to work. And now copy the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And then substitute. So negative b, I have negative 2, plus or minus the square root of 2 squared, minus 4 times a times c, all over 2 times a. All right, so this is going to be equal to negative 2 plus or minus 2 squared is 4. Negative 4 times 1/2 is 2, negative 2. Negative 2 times 3 is negative 6. All over 1. 2 times 1/2 is 1. Notice that we get negative 2 plus or minus the square root of negative 2. All over 1. Can anyone find me two numbers that multiply? Can anyone find me a number that when you square it gives you negative 2? 2 squared? 2 squared is 4. But I want two numbers to multiply and give me a negative number. Sorry, one number to multiply by itself and give me a negative number. Negative 4 times negative 4 is positive 16, because negative times a negative is a positive. Yeah, negative 2 and 1, but then it's not like a square, right? Yeah. So we can't do that with our number system. We cannot solve this problem here. We cannot find the square root of negative 2 with our number system. So one thing that we can notice here about the number of x-intercepts, here where we had get me the square root of 0, that function had exactly one x-intercept. When we said find me the square root of a positive number, in this case positive 20, that function had two x-intercepts. And then when I said, well, go ahead and find me the square root of a negative number here. I can't do that. This one has no x-intercepts. It never touches the x-axis. It turns around before it gets there. So this is all showing us one of the tools that's hiding inside the quadratic formula, and it's called the discriminant. It's a part of the quadratic formula. It's inside the square root, and it's the b squared minus 4ac. Okay? That's the discriminant. So I'd like you to get that into your notes for sure today. Get this part here. The discriminant can tell you how many roots a quadratic has. If d is positive, if you're taking the square root of a positive number, the quadratic, let's do this in typing. My handwriting leaves something to be desired. In this case, the quadratic has two roots. In this case, if d is 0, then the quadratic, it has only one root. And then if d is less than 0, if it's negative, the quadratic has no roots. So this is what d is going to be telling you in these three different situations. D can only either be positive, 0, or negative. If d is positive, you have plus or minus the square root of a positive number. That means there's some separation between your roots. There's two of them. If it's plus or minus 0, like you're taking the square root of 0, it means there's no separation between those two roots. They're actually just one point, and they happen to be the vertex. If d is negative, we can't take the square root of negative numbers. That means there are no roots. And that's what it's telling you. Yeah. So here are some practice problems from your textbook. And I'll be coming around table to table to make sure that we can conquer some of these problems. Yeah, sure. This part here? Great. I'll freeze that and stop the video. Any questions, hit me up by email.